Today we're gonna get into the actual coding bits. So I'm gonna make a new file under our environment called strings. Because strings is what we're gonna be talking about today. And you can click on this Explorer to hide that tab. So what is a string? A string is anything. This red thing here, like the red text or orange, whatever you want to call it, or brownish orange, that is a string. String just means like words. So if I hit play, this prints out this string. String works with single quotes or it works with double quotes. These can be interchanged, and what if I wanted to put in double quotes inside of the string? Like, hello, nice world. What would that do? Well, it's going to give you an error because it doesn't understand. So if you want to use this, then all you do is do a \n. Oh no, not \n, sorry, just backslash and another backslash here. So then it kind of like ignores these as the open and closers as what of the string that it's printing. So now what if I wanted to have this? So this thing here, this line, is called a function. It's a print function that is printing out a string. Now, what if I wanted to have this print function in multiple areas? Then I can have, a whole bunch of lines with stuff in between them. And that's all good and fun, but what if now you had to change the message that you're trying to put out? Well, now you have to change it in every single one. There's a way around that, and it's called a variable. So a variable is something that you can assign to something, or that's pretty complicated. It is a definition. It's like a new definition of a word. Your own definition of something. So what if I put in a variable that says my message? The definition of my message is going to be hello, nice world. So now if I hit run, I'll get a whole bunch of definitions of hello, nice world. Or I can do print my message. And if I do print, and in brackets, and in parentheses, my message, and I hit play, then it brings back my message. And notice, if I would have put double quotes around this, and hit play, it would just type in my message. And that's because this, with the double quotes around it, or if I just had single quotes like this is no longer a variable. This is a string. So this is the difference between a string versus a variable. String is like this, and variable is just like this. And variables are case sensitive as well. So now let's go back to printing out our message, the my message variable. There's a little option that you can put in here. You can put in these square brackets. Real quick, before we go any further, let's go over a couple terms. These signs right here are called parentheses. These symbols here are called brackets. These symbols here are called braces. And this thing here is a pound symbol or a hash symbol. And what's that doing is that just means it's a line of text that's ignored by your program. So this is ignored when I run my script. So that's all that means when there's a when there's a pound sign or a hash in front of something. So anyways, when I put in brackets inside of my parentheses with a variable, then I could put in a number. And if I put in 0, which is the first number, and I hit play, then it brings back the first letter of my message, which is H. And if I put in 2, then it brings back my second letter, which is actually the third because Python counts from the 0th marker. So this is 0, the first one is 0, the second one is 2, the third one is 2. No, wait, hold on. Okay, first one is 0, second one is 1, third one is 2. Next, we're going to get into our next set of terms. We have a semicolon, and then we've got a colon. So we're going to put in a colon and put in our next number. We could put in 5. This means we're going to select the second letter, which is actually our third, and it's going to print out all the way up to the 5th letter, which is going to be this space, I think. I'm not good at math, so let's just hit play to find out. Yeah, so it's going to print out these 3. Does it print out our space? I'm not sure. What if I do 6? Okay, so it prints out up until right before the 6th. So this is the 6th one, this backslash, but it didn't print it out because it stops right here before it gets printed out. If I just remove those numbers, then I just get this. If I put a -1 at the end, then it reverses it. So that's interesting, right? That's how you can reverse a message. Another thing that you can do with the variable in the print is we have some options here. We have lower with a double parentheses here. And if I hit play, then it brings everything back in lowercase letters. And if I do upper, then it brings everything back in uppercase letters. And now if I type in count without the double quotes, then I guess it doesn't know what it's counting. You have to specify that it's counting everything inside of the string. So then now if I hit play, now it shows that we have 19 characters inside the string. And just as an experiment, if we do single quotes, is that... Okay, so Python recognizes that single quotes and double quotes are interchangeable even in those circumstances. And you can even specify what part of the command you want to count. So if I type in hell and hello, then it's telling me that there is one hell inside of hello. If I type in O, then it shows us that there are 2 O's inside of our message. There's one in hello, there's one in world. And if I type in quote, or double quote I mean, then it shows that there's 2 around the nice. And this shows that E is within the first word. Another thing we can do is, if we wanted to change something in the message, like let's say we do just a print, and then we type my message again as a variable, and we type in replace. We're going to replace world with Azeroth. And we're going to do print my message. So hit play. Oh, I spelled replace wrong. And as you can see, it has not replaced our world because these variables are static. So what we have to do to change that is actually just make a new variable. So we could do new message and then my underscore message dot replace world with Azeroth. And then if we hit print, then we still get world. It's not working. All right, well, I'm not sure why the replace function isn't working. Maybe we'll get back to that in another video. For now, we're gonna press Control and Shift together, holding it down. Press P and type in add line comment, hit enter, just to comment these out because we're going on to a couple different examples now. Now we're going to add variables together to make sentences. So we could do, let's create a character. Our character's name is going to be Rupert. And that's not going to work because we need to put in semicolons to make it a string. Then we could do age. And we could do 21 as an age in a string. But we don't need to because a number is already recognized as a number in Python, so we could just leave the age as it is and it recognizes it as a number. And we're going to type in a greeting. The greeting is going to be, hello, my name is. And then we're going to do message. The message is going to be the greeting plus the name plus I am plus age. And if we print our message, we're going to get hello, my name is Rupert 21. And there's probably not going to be a space between. Okay, so we do have to put the 21 in a string, otherwise it thinks it's a mathematical equation. So we hit play, there you go. So it says, hello, my name is Rupert 21. And as you can see, there's no spaces in between here either. And we don't want to put a space at the end of Rupert because that's not his name. It doesn't make any sense. So what we could do is do greeting, then we could do a single quote, and then plus name. So now if we hit play, it puts in a single quote and a space between greeting and name. So now we have a name. But now we have to sort out this age thing because Rupert 21 is not a name either. So now we could put in a string that says plus the age, years old. So now if we hit play, we've got a syntax error here. Oh, because I forgot to put in a plus, that's all. Alright, so now this is our variable. And our variable contains 3 other variables and 3 custom strings and a few equations, which is just the pluses. So with all this put together, we get an output that says, hello, my name is Rupert, which I guess we don't need to have that. That doesn't make any sense grammatically. So hello, my name is Rupert. I am 21 years old. And then we could put a period at the end there. So that's looking pretty good. There's another way we can do this that I'll write right below here. And that is by using these braces as kind of placeholders, they're called. And here we can type in like welcome. Dot format. Greeting. Name. So if I hash this out, so we just activate this, it's going to say, hello, my name is Rupert, welcome. And the way that this just worked is this placeholder is going to represent the first variable that you put inside of these brackets. This one is going to represent the second one. So if I were to change this greeting to age, and if I hit play, it's going to say 21 Rupert, welcome. I think. Yeah, 21 Rupert, welcome. And if we replace age with name, and we have name twice, let's say, can we do that? Yep, so it's just going to say Rupert, Rupert, welcome. And the format is just showing like, so it's literally printing out this string, and inside of a string we can use these braces as like, I hope this is making sense. Braces are like hotkeys for the variables that you put inside the format, parentheses. There's an even better way to do this, and that's called using F strings. So if you put an F before a string, we can just do, like instead of having greeting and name like that, and having the dot format at the end, instead of having this whole block here, like the format, dot format with the parentheses and the variables in it, we can literally just do F greeting and name dot welcome. So now if I hash out this message, will this work? And it did work. And our grammar is all messed up because, you know, just everything is written all weird, but it works. And basically what I'm saying is this string is the same as an F string, but an F string is a bit more simplified because instead of having to write the format at the end, you just type in an F and you put your things directly inside the parentheses instead of putting the variables at the end. If you hold down Control and press A, and then hold down Control and press Shift and P, we can do remove line comment, and then hit Control P, Shift again, and then hit add line comment, and that just commented everything out again. The next thing we're going to do is we're just going to put in another thing that says test, test, and we'll make this a string. And we're going to do print test. And I use double parentheses. So in between tests, we can type in a thing called dir, which is kind of like directory. And I'll show you what that means if we press start. You get this whole input. And this is showing all of the things that you can use with this. Like for example, the lower that we used before to make lower cases. And then I think upper is in here too, somewhere. Yeah, upper is right here. We have count, which is one that we used earlier in this video. And there's just a lot of different things that, a lot of these I haven't even used, and I don't even understand a lot of these. But it's just a little thing that shows you all the possibilities that you can do with this variable and this function. So that brings us to the end of our strings tutorial video, and I'll see you guys on the next episode. Hello everyone, today we're doing integers and floats. Now what's the difference between an integer and a float? Well, let's type in number here. Number is a variable, as you know from the last video, and we could put in a number here. If we type in print and type in type num, if we hit play, our output here is class int, which means integer. Now if I do 5.1, it says this is a float. So a float is just an integer. An integer is a whole number, and a float is a partial number. So it's like 5.1. And if I put double quotes around this, then it shows the class is string. Cool, right? So that's it. Thanks for watching. Just kidding. I'm just going to grab a couple of these operators here. So these are just examples of things that you can use in your code. So let's say our number is 5 and our number 2 is 10. And if I do print, I can do print number plus number 2. And if I hit play, then it says 15 because it adds these two numbers together. Now here's the cool thing. We can also do something like number 3 equals number plus number 2. And if we do print number 3 and hit play, then it's going to print it out twice, because now it printed out this equation and then it printed out the variable of that equation. But now what if we do number 3 plus equals number 3? Here's a weird thing. Now what do we get? We get 30. Because number 3 added itself with number 3. So we can also do number 3 plus equals 1. And then do print number 3. So this is just going to add 1 to it. So we could do 31. Or we can do number 3 minus equals 5, let's say. So now what this is going to do is it's going to take 31 and minus 5 from it. And then it's going to print it if we tell it to. So I think the result here is going to be 26. And I'm right. Look at that. I'm a freaking genius, man. And now I'm just going to delete all this. And we could do number equals 3.75. And we can go print. Oops. Print doesn't go in the parentheses. The variable goes in the parentheses. We can do print number. So this prints out that number, which is a float. So it prints out the float. If we do round, then it rounds that float up. But now what if we wanted to round it to the nearest tenth of a number? Then we could do a comma and a 1. So that's going to be the first digit of the float on the other side of the decimal. So this is going to round this one. So it's going to be 3.8. If I do 74, it's going to be 3.7. The next thing we're going to get into are comparisons. So here we can do number 1 equals 5 and number 2 equals 4. And we could do a print where number 1 is equal to number 2. So now these two are not equal, right? So if I say they're equal, the print is going to print out false. So it does that equation for us. And then if we do a less than or equal to, then we get a true. Nope, false. Okay. So we're saying 5 is less than or equal to 2 or 4. So that's right, it is false because 5 is not less than or equal to 4. It's more. So if we put this thing the other way and make it greater or equal to, then it will be true. But now, if we make these strings instead of integers, then this will not bring back true. Oh yes, it will. But you know what it won't do? Is if I hit plus, it's going to add 5 to the 4, but not in the way that you want it to. See, it's going to bring back 54. But it's not actually 54, it's just 5 and 4. And it's seeing the 5 and the 4 as two different integers, but it's putting them together so it looks like it's saying 54, but the value is actually not 54, it's just 5 and 4 printed out as a string instead of numbers. But what you can do with this is type in num1 equals int num1, and if you do num2 equals int num2, if you do this now it will do a proper equation. So that's all I had about integers and floats. I'd like to thank you guys for watching and see you on the next video. Hello everyone, today we're making a new video about lists, tuples, and sets, and what the differences there are between each of them. Let's make a shopping list. Our shopping list is going to have honey, bread, and steak. Good enough. So now if we print shopping list, it's going to say honey, bread, and steak. And similar to strings, you can put in these numbers here. If I were to press a 0 here, if this was a string, it would print out the first letter. So if this was a string, which it's not, then this is what a string looks like, right? Minus these things. So this would bring back an H. Oh, or doesn't. Because it's a list. If I did this, this would bring back an H. Yeah, there you go. But because there's commas separating it, this is now a list. So it's going to bring back the first word. So let's just bring in the brackets again, just to specify that this really is a list, even though it seems like Python is implicitly believing it's a list already. But just for best practice, let's keep the brackets there to make sure that we know that this is a list. And just like the strings, we can do a 1, which means it's going to print out the 0, and it's going to stop right before the 1. So this is still only going to print out honey, but with the brackets. So if I do 2, then it's going to give me honey and bread. And if I take both of these out into a 0, or I just delete both, and I do a -1, then just like with the strings, it'll reverse it. So that's pretty cool. And by the way, the numbers that we're putting in this bracket is called an index. So the index of bread is 1, because that's the second one, and 1 is 2 in Python. So, all right. So there's something else we can do to this. We can add to the list. So we can do shopping list dot append, and append means kind of like attached to the end of it. And we can put in parentheses, and in our quote, we can put in cheese. So we're going to add cheese to the list. So now if we do print shopping list, it's going to do honey, bread, steak, and it's going to append to it the cheese, and then it's going to print it all out. Another way to add something to a list is by using insert. So if we do shopping list dot insert, then we can do 0 dash cheese. So this is saying that we're inserting it into the spot 0 where honey is, and it's going to be cheese. So that means cheese is going to get forced into the first spot and push honey forward. So that means if we hit play, it's going to say cheese, honey, bread, and steak. So here we go. If you append it, it puts cheese at the end. If you insert it into the 0 spot, then it puts cheese at the 0 spot. If we do 1 cheese, then it's going to put cheese in between honey and bread. And so on and so forth like that. What we can also do with this is we can add a separate shopping list. Shopping list 2. And shopping list 2 is going to have cereal and milk. So here we can put in insert shopping list 2. And then we're going to insert cheese. So it's going to insert all of this in between honey and bread. But it doesn't like cheese. I don't think you can do two things there. So just the shopping list 2. So now we've got honey, and then we've got cereal and milk from our second shopping list, and then we go back to our original shopping list, which is bread and steak. And if we wanted to add cheese, we could just do, we could even do shopping list 2. No wait, we can do shopping list 2 dot insert, and then we could put cheese inside of our second shopping list if we still want to get cheese. And it doesn't like that. What if we do 0? Alright, that doesn't work. Anyways, I'm just kind of messing around and experimenting here. Another way that we can add the shopping list 2 is instead of doing insert, we can do extend. So if we hit play now, okay, I'm getting a completely different error now. I'm getting an error here. Invalid syntax. You know why? Because I just entered Python mode. What's going on here? Okay. There you go. I don't know what happened there. I just hit the trash can and I just reran it. I think what happened was I'm in PowerShell mode when I'm running these, and it runs this as Python. And then somehow I got into Python mode, which you can either reset this console, or another way to get out of it is just by typing quit with double parentheses, and then that quits out of it as well. Anyways, let's get back to it. Another thing that we can do with this is we can do shopping list dot remove, and we can remove a value from our shopping list. So these are values, by the way. This is the list, and this is the strings inside of it, which are the values. So if I hit play, it has removed honey. So the shopping list brings out honey, bread, steak. It extends it with shopping list 2, which is cereal and milk, and then it removes honey and prints it out. There's also another one called, and what pop did is, if you can see this, we're missing the milk. So it kind of pops off the end of your string. So if I kept doing pop over and over after the print, then it would just keep popping them off. And why that can be useful is if you have like a queue, or if you have like a list of things, like, you know, we're checking out 10, then we're checking out 8, then we're checking out 7, and we're just like going down the list of things to do. Then we can use pop to like kind of take off the end. We can also do shopping list sort. You know what, let's just get rid of these for a second. So shopping list dot sort. And this alphabetically sorts it. So B comes before H. So we're going to do bread, honey, steak. It does the same thing with numbers. So if we do 1, 4, 8, 5, and we do numbers, number dot sort, and we do print numbers, hit play, then it's going to sort it 1457 instead of 1475. Or we can reverse them too. So we can do sort reverse equals true. And this one we could do sort reverse equals false. So this one, it's false for the reverse, so it's going forward. This one is true for the reverse, so it's going backwards sorting. We can also do some math here. So we can also do print sum of number. And then this gives us 17 because it adds the numbers together. So 1 plus 4 plus 7 plus 5 is 17. Another thing we could do is in print, we can do index. And in order to get the index out of shopping list, we actually have to type in shopping list dot index. And then in the index, we can type in honey. And it's saying that honey exists. And if we type in honey wrong, and we press enter, it just says honey spelled like this is not in the list. And another way we can do this is by typing in honey in shopping list. And it's saying true. There is a honey in shopping list. And if we misspell this, then it says false. This spelling of honey is not in shopping list. Or we can delete all this stuff, all the numbers, let's forget about this. Let's do an equation here. We can do for item in shopping list. And now item is a new word because we haven't defined that as a variable, but this is already a variable that's already set. And item in this case is string. So it's any of these strings in here. So that's just something that Python natively knows about. So if there's an item in shopping list, we can print item. And item is tied to any of these strings, so if we hit play, then, right. So for item in shopping list, then we need a semicolon here. Or is it a colon? Yeah, colon, not semicolon. Now we hit play, and then it just spits back steak, honey, and bread. So this is actually a for loop. You see how it spat it out 3 different times? That means it ran it 3 different times, and each time it gave back an item. So it gave us the first item, the second item, third item. There's also a term called enumerate, which brings back 2 items. So if we hit this, then enumerate is bringing back the place value of where honey is. So it's at 0, bread is at 1, steak is at 2. We can also do this option where we do shopping list equals join courses. Shopping list. Now let me show you what this does real quick. We have to print it first. Print shopping list. So this is separated. If I hash this code out, it's going to give me back the code. It's going to give me back the values in these brackets and the double quotes. And it kind of looks ugly. I kind of want my shopping list to be more human readable. So I'm going to hit play. And here it's separated by this. So we can separate it by dashes too. Like we can do it like this. And that's separated by dashes. We can separate it by and. So honey and bread and steak. So this whole section we talked about lists. Now we're going to talk about tuples. So now to take a look at tuples in lists. So lists are mutable and tuples are immutable. What does that mean? Well, first let's take a quick review at lists. A list has brackets containing a few values with our string in it. And we can have another variable referencing that same variable. And if we run this, this brings back, it takes the list and it takes list 2. We print out list 1 and we print out list 2. So list 2 is list 1 because list 2 is referencing list 1 in this variable assignment. So when we list just the cheese, so when we want to list something and we want to replace honey with cheese, then now we're just saying cheese, bread, steak, cheese, bread, steak. Because in a list, you can kind of pop out these variables, or you can pop out the values of the variables of which they're assigned to with another value. So we're popping out honey for the cheese, and then we're printing this back out. So now let's remove the, let's add line comments here. And then the tuple. So this is our shopping list, but let's rethink how we see this. This is our shopping tuple. This is the shopping list, but this down here, this isn't a shopping list. This is a shopping tuple. It's doing the same thing. So tuple 1 is assigned to these values. Tuple 2 is assigned to tuple 1. So if we hit play, we get an error. And we get the error after these two are printed out. See, we can still print them. We can still print tuple 1, and we can print tuple 2 referencing tuple 1. But when we try to change something in the values, we can't change it. And then it just gives us an error because it can't do it. The program doesn't work that way. So lists, you can modify the lists with these little command parameters of like popping things in and out. Different command parameters. But in a tuple, you can't change it doing that. It's static. So lists are more dynamic, tuples are static. So now let's talk about sets. What's a set? So we know that lists are used with brackets. So lists use brackets, and tuples use parentheses, and sets use braces. So if we're going to do shopping list, and stick in our shopping list there, and we type in print shopping list, we're going to press play, and we got honey, steak, and bread. Looks familiar, but wait a minute. We have honey, bread, and steak, so how can we put the steak between the honey and the bread? That's because we can press this play button as many times as we want, and it's going to give us a different order. So sets, unlike lists and tuples, doesn't care about the order. It's going to take all three of these values and just randomly spit them out, completely forgetting about what order you put them in. It doesn't care that honey is at 0, or bread is at 1, or steak's at 2. All it cares about is that there's values inside of it, and it's going to spit them out. So, a quick recap. If we have an empty list, this is defined by empty brackets. If we have an empty list, it's also defined by list and parentheses. If we have an empty tuple, we have empty parentheses, and then another way to define empty tuple is tuple parentheses. If we have sets, empty sets. One way to define them is open braces. And another way to define empty tuples or empty sets. And empty sets, a way to define them, the only way to define them that I know of, is set with open parentheses. This is not an empty set. This is a dictionary. And if you remember our previous video where we did something like print dot f, because the double braces is the things we used in F statements. They are DIRs or directories. Or not directories, dictionaries. So I hope you guys found some value in this video. I'd like to thank you for watching. Dictionaries. What are dictionaries? Dictionaries work with key value pairs. These are two linked values where key is a unique identifier of where we can find the data. The value is the data. So we can do this by starting with the value. So we're going to start our dictionary. Our dictionary is going to be called magic, and you could name it anything you want, but for this example we're using magic. We're going to type in a key. A key is going to be school, so that's our key. And then I'm going to define this key with its value, which is, we're going to do pyromancy. Now the level of this school is going to be 25. We're going to name some spells, and we can create a list here. So now we have 3 keys in this dictionary. Our first key is school, our second one is level, and our third one is spells. And the values of those keys, which they represent, is pyromancy, 25, and fireball infernio. So we got a string as our first value, we have an integer as our second value, and a list as our third value. Doesn't matter what order these are in, I'm just showing that a value can be anything, from a string to an integer, to a list, to a tuple, to a set. It can be anything that you want it to be. And essentially, a key is kind of an alias for the word that it's referring to. A key can essentially be like an index to a beginning of a book, where it shows key words that represent what you're looking for in terms of information. So if we were to write print magic and then in square brackets type in school and run this command, it would bring back the value of this key. If we were to just do print without the square brackets, it would print out every item within our dictionary. If we were to enter a key that doesn't exist, it will return a big error message saying that this is a key error. Sometimes we don't want it to return an error, or maybe we want a custom error to be returned. For this, we would print our dictionary with a get option, and then if we were to type into that same key that doesn't exist and hit play, it would return with none. So if we don't like the default method that it returns of none, then we can do a second argument to get a custom method. So for that, all we would do is put a comma and then add a custom error message. If we were to hit play on this, it's going to check the first one to make sure this key exists, and if it doesn't exist, it's going to print this out. Hit play here, we get a custom error message. If we replace damage with school, which is a valid key, and hit run, then you can see it does not run the custom error message because the check went through and found that this key exists. We can also add keys and values to our definition after we've already written it. So we can add this damage key after we already have the definition written out if we don't want to change the definition, or if we want to write it later on in the script. So now if we were to print this out, damage will be added to the end. Key is printed out as damage, the value is 10, just as we wanted it to be. We can also update already existing keys. So if we wanted to update the school from pyromancy to arcane, we could do it like this. But sometimes you want to update a lot of values and you don't want to do a separate line for all of them. So we could do them all within one line by typing in the dictionary name. We're going to use the update tool and we'll do parentheses and braces together. And we'll type in school, arcane. We're going to add a damage counter to 15, and we're going to update the level to 26. So if we run play now it's just updated some of our keys and values. We can then delete values. There's two different ways we can do this. We can do del for delete, type in your dictionary, and in square brackets we can type in the level. So if we were to play this with the print magic, then the level should not be there, and it's been removed, as you can see. Another way we can do this is using the pop. So we can define the value that we want to, so we can find the value that we want, no, not value, key. So we can find the key that we wanted to, we can find the key that we want to pop out, and then type in the dictionary name, and then type in pop to specify the option you want to use, and then we'll type in that key again. And then here if we type in magic, we can also print the level still. So the pop, it just pops the key out of the dictionary, but it doesn't delete it. So that means you can still print it out. So in this output, as you can see, the level has been taken out of the dictionary, but it hasn't been deleted, so we can still print it out. Whereas if we went back and did delete magic level, if now we hit play, now we get an error because level is not defined after this option. So that's the difference between delete and pop. Now let's go over some navigation and discovery commands you can use to explore a Python script. We can do something like print len for length and type in the dictionary name. We can run this to find how many keys we have in the magic dictionary. Here we can see we have 3, and that's correct because we have school, level, and spells. Those are 3 keys. Another print option we can do is print the dictionary name and keys. This will print out all of the keys that we have without the values. If we wanted the values, we can replace keys with values. This will give us all the values in our dictionary. We can print our dictionary and items. This will give us everything. This will give us the keys, the values, the integers, and the lists. And if we wanted to loop through our list, and if we wanted to loop through the key value pairs in our dictionary, we could do something like for key and magic. Now this for loop just basically loops through all of the keys and prints them all out. But in order to loop through the keys and values, we would need the items method to do it, and it would kind of look like this instead. And now each time this loops through, the keys and values have been listed out, and we can see all the items in our dictionary. So conditionals are controls which statements get executed by depending on whether or not a value is true or false. And as we talked about in previous videos, we know that true or false is referred to as a Boolean. Let's start with an if statement with a conditional for a Boolean check. So we're going to do if true, print condition was true. Now if we run this, this gets printed out because the condition was true. So now if we do if false, and if we press play, then nothing was printed out because false pretty much just means that our check is not going to go through. So it's like a off. So anyways, we're going to make a key value pair here. Our key is going to be weapon and our value is going to be sword. It's going to be a string. And then if weapon equals sword, print player equipped a sword. So basically, if this was like a video game like World of Warcraft, you would right click on the sword and then the player would equip the sword. Hit play. Our player has equipped the sword. So now, real quick, how come I did double equals here? Well, the double equal tests for equality in different values, whereas a single equal sign is for assigning a key to a value. See here, when we're assigning this key of weapon to the value of sword, we're using an equal, because this is like assigning. It's like defining what weapon means. Weapon does not equal sword. We're just, weapon equals sword as in we're defining it as sword. Whereas when we're comparing two, if the weapon equals sword, if these two values are the same, then we proceed. So this is like a comparison. And in order to get the comparisons down, let me quickly write out this comparisons. I'm just going to copy this over from a notepad. So here are all of our different comparisons that we can be using. What if our weapon isn't a sword? Let's say we redefined weapon down here, and weapon is no longer a sword, but is in fact a warhammer. So now if weapon is a sword, then this is not going to print out. and we can just delete these up here. So we don't get an input because the weapon was not sword, it was Warhammer. But what if we wanted to print out something anyways, like maybe some error output? And for this one, we're going to do player can't equip that. And as you can see, this looks kind of weird. The colors are different, and that's because our single quote here thinks that it's closing off after can. So we're just going to do it the easy way and put in double quotes. Another way we can do this is leave it in the single quotes and then just put a backslash before this to like void it out. So then now we get player can't equip that because that's a Warhammer, not a sword. And our player can only equip swords. So what if we wanted to add in more parameters? What if our player can equip a sword and he can also equip a Warhammer? So then we could do player equipped a Warhammer, and our else we're going to replace with something called elif weapon equals Warhammer. Then we're going to print out this statement, and then player can't equip that. So now if we run play, if it's a Warhammer, then the player equipped a Warhammer. But if we change weapon to sword, then player equipped a sword. But if we change it to axe, then player can't equip that. So what if we want to add an axe? We could just keep adding these elif statements and keep modifying them. So we could do like axe here. So then we hit play, player equipped an axe. So now our player can equip 3 different weapons. And now I just want to add some additional comparisons that we can be doing with our Boolean operators. And these can be and, or, and not. So some examples of how we can use these is, let's say we have a user, an admin to our video game, and we want to check whether or not they're logged in. So if they're true, then we would have if user admin is logged in, then we will print admin is online. But if they're not logged in, then print admin is offline. See, this is an if statement checking whether or not these values are both true. So if the user is admin and they are also logged in, then it's going to print this out. But if the user is admin and they are not logged in, then it's just going to print this one out. Whereas, see if I hit play, it says admin is online, but if I change false, then it's going to say admin is offline. But if I change and to or, and they're offline, and I hit play, then it's going to say admin is online, even though they're not online, they're actually offline. And this is because with the or statement, it's just checking to see whether or not one of them is true. It doesn't care if both of them are true, it just wants one to be true. And if one is true, it's going to say admin is online, even though that could be false information. And then we can get into this not statement, which we're going to use a bit different. So this one, instead of comparing to or checking whether or not 2 is true, we're just going to do if not logged in, then it's going to say admin is online. And that's because we kind of have this backwards right now. So now we should have done offline at the top here and online at the bottom here. And if you wanted to do it the other way, then you would just type in if logged in is true. And it says false, but if we do true here, then we get admin is online. And now talking about object identity, you can test if objects have the same value by making 2 different lists. For an example, we can do A equals 1, 2, 3, and B equals 1, 2, 3. And if we do print A equals B, then this will say true. And there we get a true. Let me just clear this out and hit play again. So yeah, we got a true here. And now if we were to do print ID A and print ID B, we can just use these to validate that these identifiers look the same. So here it looks like we got 2 different numbers, which is interesting because they are different, but it says that they're both equal. So A is 1, 2, 3 and B is 1, 2, 3, but when we print them out, they're both kind of different. But when we do print is equal to B, they are both the same because the lists are the same, like the values are the same. So, but if we were to do print A is B and hit play, then it says false because as we can see, they are both different. And even if they were the same, they would still show as false
because A and B are still uniquely identifying their own strings, even though they're the same. Whereas if you did B equals A and you typed play, then it would say true, and the numbers would be the same. Because now B is no longer a self-unique identifier, now it's identifying as A. And print A is B is actually just a shortened version of print ID A equals ID B. Or if you did is. So it's is, or if you're doing the equal, then these two are the same. So these two are the same. This is just a shortened version of this. So this is kind of like the long form. So just a few more pointers with booleans. So in this example, our condition is going to be false. And if the condition, and we're going to do an if statement for if condition, print evaluated to true, then we'll print this. Otherwise, our printer will evaluate to false. So now if I run play, this evaluates to false because our condition is false. If we put our condition in as none, it's going to do the same thing. If we do our condition as 0, it will do the same thing. Whereas if we put in 10, it'll say true. But a 0 is false. And any kind of empty sequence, like if we do double quotes like that, then it is false. Whereas if we add in a string, then it's going to say true. Same thing with double quotes. This is true. Whereas if we leave it empty, it'll be false. Same thing with parentheses. This is false, but this is true. And with brackets, this is true. And then last with mapping. So with the braces, you put nothing in them and they're just false. Loops and iterations. We're going to do for loops, while loops, and I think those are the only loops we're going to be doing in this video. So to start this off, we're going to make a list. It's going to be nums for numbers, and we're going to write out our first for loop, which is we're going to do for num in nums. We're going to print a num. So basically what this is going to do when we hit play is that every time it loops through, it's going to go ahead and print the first number, then it's going to loop through the script again, print the second one, third one, fourth one, and fifth one until it's done. So when I hit play, it'll just give me all the numbers in this list. So here it is, 1, 2, 3, 4, 5. We have two loop keywords. We've got break and continue. Those are our two fancy words for this video. The first one, break, the break statement looks for a value in our list, and once it's found it, our loop stops. And the loop doesn't need to continue once the value is found. So here's an example of how we would use the break statement. So for num in numbers, let's say we find the number 4. We're going to do print found 4. And that's like going to be the message it prints out. And then we type in break. So now this for loop is going to loop through all of these until it finds 4. And it's going to print out 1. It's going to print out 2. It's going to print out 3. And it's not going to print out 4 because check this out. So the first time it goes through all 5 of these lines because it did not find a 4. Because none of the first 3 is number 4. So it's going to ignore this, and these two lines, the print and the break line, is completely ignored by 1, 2, and 3, and 4. So it goes directly here and it prints it out. But 4, since it does not ignore these two lines, it then reads the break and it does not continue. So it will not print out 4. And it, of course, will not print out 5 either because it just stops doing everything. So here is our example, 1, 2, 3, and then it found 4. So the other option we got is continue. So continue is the same kind of, so the continue statement will continue looping through the list even after the value it's looking for has been found. It still won't print the number So it's still gonna just print out found 4 and then hit continue, and then it's gonna print out 5 after it loops back around again. But it's not gonna print out 4, it's just gonna print out find 4. We can also do something where called a nested loop. And a nested loop means that we put a loop inside of a loop. So a loop in a loop, like loopception. So for this example, for num in nums, it's going to take 1 and go through with 1, and then it's going to bring it inside of this loop inside of this loop. And once it gets in here, it's got to run through this loop every time until it goes through A, B, and C. So it has to go through all 3 letters before it gets out of the loop, meaning it's going to do 1A, 1B, 1C, and then it's going to go to the next loop and do 2A, 2B, 2C, 3A, 3B, 3C. So if I hit play, that's what we should get. And yeah. So we got to be careful with nested loop because it will go through every single combination. Now, sometimes we will want to go through a loop only a certain number of times. If we want to run through a loop only 10 times, we can do something like for I in range of 10, print I. So we can delete this as it won't matter anymore. So essentially what this 2-liner for loop is going to do is it's going to print out every number up until the number 10. And before it prints out 10, it's going to stop. So the 10 won't be printed out. It's going to go up to 9, and it starts at 0. But what if we want it to start at 1? Well, we can specify the range to make it start at 1. So 1, 10. So this is going to print out 1 all the way up to 9. And if you want it to print out 1 all the way up to 10, then you just change the 10 to an 11. Now let's talk about while loops. While, that's our keyword right now. A while loop runs until a condition is met. So we can set a key value pair here. Our key is x and our value is 0. So now while our key is less than 10, we're going to print out our key and we're going to add 1 to it. So right now our key is 0. The value of x is 0. So right now 0 is less than 10. So it's going to print out this number. But after it's printed it out, it's going to add 1 to it. So next time it loops through, the x will now have a value of 1. The next time it'll have a value of 2. It's going to do that all the way up until the value is less than 10. So up until it's 9. We can add break and continue statements within our while loops. So if the value of our key x is 5, then we could do a break. This means when we run this, the 0 will increment all the way up to 4. But once it hits 5, it's going to loop through it one last time, and it's not going to print it out. So our output is going to be 0, 1, 2, 3, 4. And it didn't print the 5 out because our print statement is after the break statement. Once the break statement is run, the code will not see it any further. Sometimes you want an infinite loop that continues running until there's an external input that stops it. In order to create an infinite loop, we can pretty much just hash out these two. So, and then instead of doing while x is greater than 10, we could just do while true, print x, and add 1 to it. So we don't have anything telling it that it's not true. So if we hit play, this is now an infinite loop that's just going to keep going and going and going until an external input comes in and interrupts it. And in this scenario, that's external input is going to be me pressing Control C. In most environments, you could press Control C to break out of the infinite loop. That's all I have for this video. Thanks for watching. Functions are instructions packaged together that perform a specific task. To create a function, you use a def keyword which is short for definition. So if we're to start off, we can create a definition and name it whatever we want. We can name it something like taco funk. We can name it taco function or just taco funk for short. But we're going to make this one about magic. So magic funk is going to be our function. And we're going to add these empty parentheses that are just going to sit empty. The empty parentheses is just there because it has to be. That's where we put function parameters, and even if we don't have any function parameters yet, we still need to put that there because our function will complain if we don't, because it's looking for our function parameters. So we just give it the empty parentheses to make it happy. And we can even type in this pass. So what the pass is telling the function is that, yes, I know there is nothing in the function, just ignore it and don't give me any error output over. So if we hit play, it's not going to give us anything. Now we can write something like print magic funk. If we print this out, it's not going to print out what the function is. It's just going to print out where the function is located in our memory. So this is just a location in our memory block, like in the RAM, and it's just showing us where it is, but it did not execute anything. In order to run this function, we have to put in those empty parentheses to show that we're running this function and not just looking for it. So if we hit play, it's going to return with none. And it's returning none because this is essentially a Boolean that's showing false. This would be the same as if we had empty brackets, empty braces, empty quotes, empty double quotes. We had like a video a little bit earlier than this one about Booleans. And in that video, we talked about all the different types of Booleans and how a lot of the false Booleans are just empty parentheses that equal to none. So if we were to delete the print and just run this as a function, we just wouldn't get anything because it's not printing out anything. It's just running it, and we're not telling it to print anything. But let's say now we can actually add something into our function. Let's add a print function inside of our function. So our print is going to say this function is magic. So now if I run this function, I'm going to get this return because we told it to print something out. Functions allow us to run our code without repeating ourselves. There is a term in programming called dry. Dry code is when we don't repeat ourselves throughout our code. It keeps the code dry and clean. Dry actually stands for don't repeat yourself. In order to keep dry, clean, organized, simple code, it's best we use things like function as much as possible to avoid repeating blocks of code that don't need to be repeated when we can just use the function instead. Because imagine if we had code like this. So now this is going to print out this function is magic 7 times, including the defined function. So if we hit play, we get a lot of things that says this function is magic. But as we can see, our first line says the function is magic, and our other lines say this function is magic. So what if I wanted to change all of these to the function is magic? Well, now I have to go into each one of these print statements and change this to the. And that's not a big issue right now, especially in VS Code where we can just highlight all the is and change them all to an E to make it the function is magic, but then that would also replace these. You know, it's kind of like a bit of work and hassle, especially when this print statement is found throughout 1,000 lines of code or maybe even in different files. So it's a lot easier to keep the code dry and just use the function instead of printing it out over and over again. But sometimes printing the function is not what we want. Sometimes we want to return a value with our function. And returning a value is different from printing in the sense that return means we execute our function. It's going to be equal to our return value. So these executed functions here are equal to the string, this function is magic. But if we change it to, instead of doing print, we can do return. Return the function is magic, and we run magic func. This doesn't bring back anything because it doesn't tell us to print, it just says return. So in this case, we would have to just do print magic func, and this would print out the function is magic. A function is essentially a machine that takes input and produces a result. If you've ever played a game like Factorio or Satisfactory, this is the equivalent to a machine where you insert a copper plate and the machine outputs copper wire. And you as a player, you don't need to know how the machine is making the copper wire out of the copper plates. All you need to know is that there are copper plates going in and copper wires coming out. So now let's try one of these input-output mechanisms. So you might have seen this one before, print len copper. So print is our first machine, and we're inserting len into the print. So len is our first machine, or factory. We're inserting copper into the len factory, and the len factory is going to take that copper and return a value out of the copper. And it's just going to tell us how long the copper word is, and it's 6 letters long. So we don't know what this len is doing in the background. We don't know what the code is behind it or how it's turning the copper into numbers. All we know is that we gave it copper and it gave us a number. And to be honest, we don't really need to know why length took copper and gave us a number or how it did it. And we don't really care about it. All we care about right now is that we're giving it a value and it's giving us a value back. So this is a little peace of mind to know that you don't need to know how all of these different statements work. I know when you first get started learning coding, it's so easy to get caught up with why is it this word? What does this do? Why does it do it like this? So many whys, but it's important to just accept that you don't know and you aren't going to know until later when you're really good at coding. In the beginning, you don't need to know because I'll be honest, I don't even know why or how a lot of these functions do the things that they do. I just know that I put in the data and this gives me a different output. So knowing that, we can chain functions together. So we can do a function like, we can do the print function and then give it another function which does upper. So this is just going to print our output in an uppercase format. So print is the factory, we're putting in magic func, and we have an extra module on our factory, kind of like chained onto it that gives us an extra output. It kind of changes our output a little bit. Now let's do some updating to our function. Let's make use of these blank parentheses. I'm going to put in school. As a lot of you nerds out there, magic has different types of schools. So a school of magic can be like the restoration school, conjuration, destruction, pyromancy, illusion, alteration, lots of different schools of magic. So we're just going to get nerdy with this. And the return that we're going to use, we're also going to kind of edit this. And we're going to do a double brace here and function. So this output is pretty much saying that these braces represent what the school is. So this is where our school is going to go. That's our first function. And then it's going to type out function literally. And then this is just showing the format. So school is going to be where these braces are. So if I hit play, then it's not going to work yet because we need to specify, because we haven't specified a default output. So like we could specify something like conjuration. And then if we hit play, then by default, because we didn't give it a value that we wanted to, conjuration is the default that it's just going to give us. But if we type something in here, like let's say illusion, and we hit play, then it's going to replace that with illusion because this is what we're telling it to print out here. And we could change this to anything. So we could change this to like fire, and it's going to print out fire. We can change this one, conjuration, to frost, and we can delete fire, and it's going to do frost function. And now we can add extra parameters to this too. So we can add like spell. So our spell can be like frost blast, or let's say blizzard. Blizzard sounds pretty cool. That sounds pretty icy. So now if I hit play, it's going to not give it out because we haven't specified in the return to return that. We're saying that the function has some values in our parentheses. One is spell equals blizzard, but we haven't told it to return anything to do with that yet. So what we can do is add it into here, and then the format, so here's the placeholders. If I were to run play right now, it's still not going to give back blizzard because now it's just going to give an error because there's a set of placeholders here that we haven't told the program what we're returning in these placeholders. So we gotta make sure we update the format to spell. So the spell is gonna go into these placeholders. So if I hit play now, then it's gonna say frost blizzard function. And if we were to switch these up and do spell spell, then it's gonna do blizzard blizzard function. And if I were to put school here, then it's gonna do blizzard frost function. And if we want to separate these with a dash instead of a comma, then we could just put a dash here. We could put an equal sign here. We can get rid of function altogether if we don't want that written. So now it's just blizzard equals frost. So just play around with those to see the different outputs that you can get by messing around with the orders of all these. And of course, if we don't want the defaults, then we can do some specifications. So we could do illusion and visibility. And then if we hit play, it's going to do invisibility equals illusion because that's how we have it written out in our return. Now let's go on to do a different type of function. This function, we're going to do two key definitions. Our first key definition is going to be schools, and we're going to add in a list of strings. So we're going to do pyromancy is one school of magic, enchant is another school of magic, and illusion is also another school of magic. And we're going to have different spells in here. For this example, we're going to do a dictionary here, which is just going to be a set of arguments. So our spell is going to be fire blast, and its damage is going to be 30. So we're just going to have one spell in here, and it doesn't like it here. Something doesn't like something. That's because I forgot the semicolon after spell. So our definition of our function is still going to be magic func. We're going to keep using it. And then we're going to have a star school and double star spells. Or sorry, schools and spells. And we're going to do print schools and print spells. So now we have stars, as you can see. What do the stars mean? Well, one star is unpacking positional arguments, whereas 2 stars is unpacking keyword arguments. And as we can see, schools is showing us a list of strings, and spells is showing us key value pairs, which are keyword arguments. There are 2 keywords to take away from this. There's args and there's quarks. Those are kind of weird words, and I didn't like them either at first because they confused me, and they made me feel like I didn't really know what was going on because these are kind of weird looking words. But args is just short for arguments, and quarks is short for keyword arguments. And args, arguments, are just like these different strings within this list, whereas keyword arguments is saying that here's a key, and here's a word, and then here's the key, and then here's the value for it, key and value. So it's like key value pair. Spell, the argument to spell is that it's a fire blast. Here's damage, the argument to damage is that it's 30. So we put 1 star when it's just a argument, and then we do 2 stars if it's a keyword argument, such as this spell and fire blast combination, which can also be names. And then we could do like name is Rupert, and his age can be 30. So this would be a different keyword argument. And for skills, he has blacksmithing and long blade. So here's another one where skills is the args. So this would be the same as star args. And then all of his stats would be the quarks. So the list of skills that Rupert has are the star args, and the stats that Rupert has are the quarks. So you know this would be things like level. This would be things like his birth sign, his height, his specialization. Whereas the skills would be stuff like long blade, heavy armor. You know, just a bunch of examples. I'm going to delete this, but so that's kind of a way that you can compartmentalize arguments and quarguments if you're a gamer. So now if I hit play on these, it's not going to output anything because we might have to actually do magic, func, schools, and spells. So now if we hit play, now it will run and unpack all of them. So now it's unpacked our args and it's unpacked our quarks. So this was a pretty crazy video, a lot to take away from this, so I hope it made sense. Thanks for watching.
Hello everyone, just wanted to go over a calculator that I coded in Python. This is a super basic video, just something that I created. In my GitHub profile, under repositories, I've got this basic calculator, just one file. It's very humble. So I'm just gonna take the code and copy paste into Visual Studio Code. Originally I was gonna call it candy math. So as we know with Python, or any language, whenever there's hash signs, that means this is just documentation and this is stuff that the program is going to ignore. This is just for us humans to read. So from the first line, I'm importing a sleep function from the module time. I'm defining here a function. It's going to be boot up candy math. Function of this is we're going to print this statement, and then sleep means that it's going to wait 0.5 seconds before going on to the next line. So it's going to print the next message, then it's going to sleep again, print the next message, sleep again, and it's just going to print out all these messages all the way down to the bottom. And the reason why I put in the sleep functions from the time module is to give it kind of a DOS, old school Nintendo startup kind of vibe. So if I were to hit play, you can see that it's starting up and it like slowly pops up here, slowly draws out the calculator, and then we've got 4 operators here. We have add, subtract, multiply, and divide. Before we get into those operators, let's talk about the logic behind this. So first we have to define add. Add is going to be x and y in the parameters, and then our return value is going to be x plus y. Python natively already understands what plus is, and it understands what integers are. We don't know what x and y is yet, so those are kind of our filler spots, like our a and b, x and y. It could be, next we have our subtract value, and again our parameters are then returned with x minus y. Our multiplication function, we define multiply with our 2 placeholders, and it's going to be return x times y. Then we have a divide, same thing. And then this is our print section. So far, we haven't input anything. This is where we're about to do some user input. And it's just while, it's going to be a while loop. So while true, take input from the user. So true, we actually didn't give it anything to be true or false. So that way, it's just true no matter what, because there is no false, because there isn't really a condition that we gave it. So we're going to take an input from the user. We have 1, 2, 3, and 4. And inside our while loop, we're going to put in an if block. So if choice in one of these numbers, then we're going to have a number 1 that is going to be the first number that the user enters. Then we're going to have a number 2, which is the second number that the user enters. And then we're going to go down the choices. So if the user chose 1, this means that it's going to do addition. And if the user were to do 2, that would be subtraction. If the user were to do 3, that'd be multiplication. And if the user were to do 4, that would be divide. And here, where we do add and subtract and multiply and divide, these are our functions that we defined earlier on in our script. And if the user doesn't enter any of these numbers, then we're just going to get back a value that says invalid input. A lot of times in code, you might want to put in the errors before all the functions, or you want to put it after. Some people like to put all the debugging stuff before all of this begins, just to kind of optimize it. Sometimes I see it after. I guess it depends on what you're scripting. For this script, it's very humble and it's a very simple script. It doesn't rely on any other files. It doesn't even repeat. So at the end of this, no matter what you do, it's just going to close out of it anyway. So this isn't really a program. It's nothing sophisticated. This is not a good script. This is just something that I made that I just wanted to show off. So hope you guys liked it, and I hope you learned something. I'm just gonna start writing a little script that I've been reviewing quite a bit. So this isn't totally off the top of my head. I've just been studying and practicing a lot. So we're gonna do this multiplication table that's gonna multiply up to 10. We're gonna have some columns for our display that'll make it pretty to read and look at. So do column values, and then it's gonna be a for loop script, so for I in range. We're gonna do rows plus 1, for j in range. We're gonna do columns plus 1. And this is gonna be for the inner loop, inner for loop. So this for loop happens inside of this other for loop, so it's kind of like a nested for loop. And then we do c equals I times j. So those are our two values, our two variables. Print is 2D. And I'm showing how I want to format it. And then if I hit play on this, rows is not defined. Oh, yeah, because this has to be rows. So now if I hit play, so it does 1 times. So here we've got a multiplication table. So it's like 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 4 times 6, you know, you can look at it either or. And that's kind of how I do this multiplication table. This is a really rough video. I didn't really explain anything, but I'm still kind of learning all this stuff myself. But hope you found something that you learned or found something useful. I'm going to copy and paste this into the description below so that you can put it into your own Visual Studio Code and analyze it and play around with it. So thanks for watching.